Okay, today we're talking about exponential functions. And there's a general form, and it looks like this. It's going to look like y equals b to the x minus h plus k. Okay. And here are all the different things that affect it. If the b is negative, it reflects over the x-axis. And the second part of the b is if the absolute value of b, that means looking at it without the negative, if it's less than 1, it's decay. And if it's greater than 1, it's growth. And you learned that in Algebra 1, but a little review doesn't hurt. The h, the value of h, and notice it's being subtracted, so it's the opposite of what it looks like, tells you if it shifts left or right, and the k tells you if it shifts up or down. And the k also tells you the asymptote. And your asymptote is always going to be y equals k. And remember to write your asymptote as an equation. Don't just put k, whatever k is, but make sure you write y equals k, and that's your asymptote. All right, so if we look at the first one, okay, y equals 2 to the x. First thing we're going to do is do a table. And my table is x and y. And as a general rule, you're just going to use -1, 0, and 1. The -1 gives you a value to the left of the axis, the zeros will get you your y-intercept, and then the 1 will tell you on the right of the axis, and that gives you enough information to kind of see the general curve of it. So -1, if I plug in -1, 2 to the -1 is 1/2, or 0.5. So -1 and 0.5. If I plug in 0, 2 to the 0 is 1, so 0, 1. And then if I plug in 1, 2 to the first is 2. So they're all real simple too. Okay, so it looks like this is coming half, and then it starts going up this way. Okay, that's the general rule. My domain going from left to right, remember, and you're looking at your function, it's pointing out to -infinity, and then it's pointing to the right. So the domain goes from -infinity to +infinity. Remember, range goes from bottom to top, like filling a bathtub. So it's -infinity to +infinity. And it's approaching the axis and it's never going to go below that. So I don't have anything down here. I don't have any values until about 0, but not including it, and then going up through +infinity. So that's going to be my range. My asymptote is the horizontal line that goes through 0, so it's y equals 0. So that means that this is a growth equation. Okay, we know it's growth because, first of all, the b is greater than 1. And if it grows away from the asymptote. So it doesn't necessarily mean it goes up. It just means it grows, like from left to right. If it grows away from the asymptote, that makes it a growth function. And for these, I just plugged these in for the 2. So that was like y equals 2 to the -1 was how I got 0.5. Y equals 2 to the 0 was how I got 1. And then y equals 2 to the first was how I got 2. Okay. So that was a basic function. We didn't have a k, so that's why part of why our asymptote was at 0. Okay, so we're going to take that. That was our parent function. And it was a base 2 parent function. And now we're going to use some of those tools to figure out how we're translating these on the graph. So I've got 2 to the x plus 3. That's my k. And that means it's going up 3 because k tells you up and down. That's the only change that I have from the previous one. I'm going to do x and y. I'm still going to do -1, 0, and 1. So if I have 2 to the -1 plus 3, okay, 2 to the -1 is 0.5 plus 3 is 3.5. 2 to the 0 plus 3, 2 to the 0 is 1, and 1 and 3 is 4. And 2 to the first plus 3, 2 to the first is 2 plus, whoops, 2 to the first is 3, 2 to the first is 2 plus 3 is 5. So I'm going -1 and up 3.5, 0, 4, and 1, 5. So it looks like this is coming like this. All right, and we know our asymptote is going to be y equals 3, because 3 is our k, and your asymptote is always going to be y equals whatever your k is. Then for my domain and range, negative to positive infinity first on my x's. Your domain are your x values, so I'm going from negative to positive infinity. Your range is always going to incorporate your k, because my range doesn't start until my asymptote. And so it starts at 3 and then goes up to positive infinity. And we always use a parentheses because we're not including 3. This is also a growth function because it's growing away from your asymptote. Plus, our base is greater than 1, so we know that that's a growth. Okay, next one. I've got the plus 2. That's my k. That means I'm going up 2. That also means that my asymptote is y equals 2. I've got y equals x minus 3, or excuse me, 2 to the x minus 3. That means my h, it's subtracting 3. It's always the opposite of what it looks like, so my h is 3, which means we're going to go right 3. And we're going to have a parent function. If I had the parent function, like the one I did in number 1, I would use -1, 0, and 1. But I'm adding 3 to that, right? Because we're going right 3. So if this is my x of my parent, so the x of this function, I'm going to add 3 to my parent. Okay, and let me stop and just do that again because I know that tends to be confusing. The parent function is what would happen if we just had the base to the power and we didn't have h or k at all. Okay, and when, you always put -1, 0, and 1, or it's a good rule of thumb to use those for your parent. But now we're shifting the center of this all over the place. My new function is to the right of the parent by 3. So whatever I used for the parent, I'm going to add 3 to it here. So I have -1 plus 3 is 2, 0 plus 3 is 3, and 1 plus 3 is 4. And then I'm going to plug those into my equation to find out what my y value is. So I've got y equals 2, my x is 2, so 2 minus 3, to the 2 minus 3, plus 2, which means I've got 2 to the -1 plus 2. 2 to the -1 is 1/2, or 0.5, plus 2, so this is 2.5. I'm going to do the next one, y equals 2 to the 0 minus 3, or excuse me, 2 to the 3 minus 3, plus 2, which is 2 to the 0 plus 2. 2 to the 0 is 1, and 1 and 2 is 3. And then for the last one, I'm plugging in 1 for my x. No, I'm plugging in 4, sorry. 4 for my x, plus 2. That gives me 2 to the first plus 2, and 2 and 2 is 4. So I've got over 2 and up 2.5, over 3 and up 3, and over 4 and up 4. And so this is, again, going up like this. And we know that my asymptote is y equals 2, so that makes sense. It's approaching that asymptote. And remember, this keeps going on and on. It doesn't stop there. It's going to go out forever and keep approaching that asymptote. So my domain from left to right is going to be negative to positive infinity. My range from bottom to top, remember that your range is always going to incorporate your k, and I don't have any values till I get to 2. I'm using a parentheses because I'm not including the 2 because it never actually touches it, and then that goes up through positive infinity. Okay, next one. This one, the absolute value of my b here, this time is less than 1, okay? All the previous ones, it was 2, so it was greater than 1. So that means this is going to be a decay function. Okay, and a decay means it decays towards or goes down towards the asymptote. All right, but one step at a time. Okay, I'm going to do x and y, and I'm going to do -1, 0, and 1. So if I have y equals 1/2 to the -1, okay, remember that you're going to flip it, so that's 2. If I have y equals 1/2 to the 0, anything to the 0 is 1, and y equals 1/2 to the first, that's just going to be 0.5. Okay. I don't have a k, so my asymptote is going to be at y equals 0. It doesn't ask for it here, but your asymptote is at y equals 0. All right, I have -1, 2, 0, 1, and 1 and 0.5, so this is coming down towards the asymptote. And that fits with what we said about decay, because if it's decay, it curves towards the asymptote. And I don't want you to say that it goes up or down for growth and decay, because that'll mess you up when we get to some things later. So I want you to get in the habit of growth grows towards the asymptote, and decay grows away from the asymptote. Okay, next one. Looks like my asymptote equation was back here. Went to the next page, but we can just do this. Oh, I didn't do domain and range either. Okay, domain, left to right, negative to positive infinity. Range, bottom to top, again, your k is incorporated, so that's 0 to positive infinity. And then my asymptote, I didn't have a k, so my asymptote was y equals 0. Okay, so that was our parent function for 1/2. Okay, and the next thing I'm going to have is I've got a negative out front. Okay, when my b is negative, that means that it's going to reflect over the x-axis. Okay, from what my parent function was. I'm going to do my table. Okay, we don't have a k, so I know my asymptote is y equals 0, so we can go ahead and get that out of the way. Okay, and I've got -1, 0, and 1. If I have y equals -1 times 1/2 to the -1, oops, that gives me -1. 1/2 to the -1 is a positive 2. Okay, the -1 just makes us, remember, negative exponents just mean we flip it, which means I'm going to have -2. If I have, and I'm using it, if you're asking about why it's a -1, I have a negative in front of this. I'm just making a -1 just to keep clear that the negative is separate from the actual fraction. And then I've got 1/2 to the 0. 1/2 to the 0 is 1, so -1 times 1 is -1. And then I have y equals -1 times 1/2 to the 1, which means I have -1 times 0.5, which is -0.5. So I have -1, -2, 0, -1, and 1 and -0.5. Okay, If you have what it was before, it was coming down like this, and so they've taken it and flipped it over the x-axis. They took it and flipped it over the x-axis. Okay. Now that's different when you have a negative in your exponent, a negative x. That means it reflects over the y-axis. Okay. Again, I don't have a k, so my asymptote is going to be y equals 0. Got my table, and I'm going to use -1, 0, and 1. So y equals 1/2 to the opposite of -1, which is going to be 1/2 to the positive 1, so that's 0.5. I have y equals 1/2 to the -0, which is just 1/2 to the 0, and anything to the 0 is going to be positive 1. And then I have y equals 1/2 to the opposite of 1, which is 1/2 to the -1. So I flip that, and y equals 2. So I have -1 1/2, 0, 1, and 1, 2. And so this one is going this way. And what we did is we took the original one and we flipped it over y. It was coming down, okay, we flipped it over y. And that was the main difference for that one. Okay, and that's all we've got for today. Thanks.